Today I'm going to show you guys how to build a Solana decentralized mobile app where users can log in using any Solana mobile wallet they have on their phone. Thanks to the Solana Mobile Wallet Adapter, they can view their balance, they can send tokens to any Solana wallet address, receive Solana using their own wallet address, and then request airdrop from Solana faucets. They can as well sign message to their wallet. Let's say hello world to Solana. Click sign message, verify. You can see hello world to Solana, confirm, sign message with this is your wallet address. So yeah, and all this will be done using React Native on Expo CLI. To get started, we open our browser and type docs.solanamobile.com. This is it. This is the developer documentation for Solana, for building on Solana Mobile. You come down here, React Native, create a project, and then this npm create Solana dApp at latest. We copy it, open our terminal, we navigate to the directory where we want to store our projects in. As for me, it will be in document/react native/dApp and then paste npm create Solana -dApp at latest, and this is going to clone the template from the official Solana GitHub, and then we're going to work with that. Project name Solana dApp. Select a group Solana Mobile. We have web3.js Expo and then web3.js Expo paper. This web3.js Expo paper is going to build using the Expo CLI and React Native paper, but then we'll just go with plain Expo CLI React Native. We'll click enter, loading templates. It's done installing, and then next what we're going to do is cd Solana dApp, and then I'm using VS Code to code dot. This apps folder is going to be holding our UI and interface, assets, fonts and images, components, some other few components, as you can see, QR code, splash control, theme, drop down, constants, some app config and colors as well. We have hook for the themes and track location, node modules, utils, lamport to Sol. Normally when we're using the Expo CLI, we use the Expo Go to simulate our project, but then this Solana mobile stack has these two packages which access native features of our mobile phone. Therefore, we can't simulate it using the Expo Go. The best way to do that is using development build. If we go back to our documentation, that was here. This was where we stopped, and then we did all this. Next step, environment setup. Expo is the official recommended framework to build React Native apps. Yeah, as you know, we recommend Expo setup, Android, development build. As you can see on the official documentation, development build is needed. You can't use Expo Go. To generate a development build on Expo, there are two ways. Either you use Expo Application Service EAS, or you use a local build on your machine. And the local builds are mostly done on Linux and Mac OS. Windows barely supports local build, but then there's a workaround if you are going to do a local build on your Windows machine, and that's what I'm going to be doing today. So I'll show you. For those of you that want to use development build on ES, development build EAS Expo document, create a development build on EAS. Come to this documentation and follow these steps. You install Expo Dev client, build it, use EAS CLI, and then you log into EAS and then you run this on your terminal. It is going to build it. This is for Android. And then I think, yeah, this is for iOS. For an iOS simulator, you do this as well. Native build iOS device. So after you've done this for Android, after you've done this, then you install it. And then you can also check the progress while it's building on your EAS dashboard. To see when it's done, then you download it from the EAS dashboard. But then most times, most limitations that we get on EAS is that you get concurrency limits, meaning monthly you have a limit of number of builds that you can generate if you are on the free tier of EAS. So therefore, always building and building and building, and then it start getting slower by the time goes because you are almost reaching your limits. And one thing developers is we don't have time to waste. So I'm going to be showing you guys how to run this locally on your Windows machine. To get started on building locally on your local machine, if you don't use EAS, first off you need to download Android Studio for Android. If you're going to use iOS, you're going to need Xcode for that, and it will have to be on the Mac OS. So then this is Windows, so you can build for Android. So you come over here after you've downloaded your Android Studio and you've installed everything you are asked to install. You come over here, more actions, SDK manager, come to languages and frameworks, Android SDK tools. Make sure you download the latest Android SDK build tools. Download the latest NDK. As at the time I was installing my Android Studio, this was the latest, so I have it installed. Skip this. Download the latest CMake, and then Android emulator hypervisor driver, and Android SDK platform tools. Install all this, and then once you have those installed, you come back here, more actions, virtual device manager. This is where you're going to be viewing your virtual devices that you're going to work with. You choose the phone you want and make sure it has Google Play services installed, because you're going to be needing it for some other projects. So but then I'm going to be using my physical device because my laptop RAM is not heavy enough to hold a virtual device. You're going to be needing minimum of like 6 gig RAM, and then close. What I'm going to be doing is to run it natively to my mobile phone, my physical mobile phone. This right here is my physical mobile phone. I just connected it to a phone mirroring software that allows me to mirror my phone to my laptop. This process I'll be showing you here now is going to work for both physical device and a virtual device. So the first thing you do is to install your Expo Dev client, and then we're going to do that with npx expo install Expo Dev client inside your project directory. That's where you're going to install your Expo Dev client. Our Expo Dev client is done installing. The next thing we're going to do is to generate our native Android folder since we're building for Android. So to do that, we are going to run a pre-build. Pre-build is basically prepping our project to become a development build. So we start npx expo pre-build. You're going to see an Android folder coming up here. So let's see, creating native directory Android. So that's where our native features are going to be accessed from. If you're going to be making any changes to your app.json, we run the pre-build after you've made the changes. Like you're trying to change your app name or your app version, your icon, background color, whatever it is you're changing from this app.json. After you've changed it here, you have to run a preview again, so that is going to change them to the native features under your Android. Our preview is done and our Android folder has been generated. To run a development client now, you're going to type for EAS. Remember, we also installed our Expo Dev client. So now for EAS, after you've logged in and everything, you type this into your terminal and then it's going to run an EAS build. But then I'm not using EAS, I'm going to use a native build on Windows. So it's going to take a different approach. So the first thing we're going to do is to download our Gradle zip folder. While we're downloading this, normally when we run npx expo run Android, when we run this, normally it's meant to start bundling our development build. But then, according to our Gradle Android native features, it is going to download a Gradle zip from this URL. And downloading this is like 130 MB, which is going to take a lot of time if you are running behind a slow network provider. And for every development build that we're going to run, we are going to be needing this Gradle zip. This is not going to be our first mobile app we'll be building, and then we can't keep building and downloading a Gradle zip file every time we're trying to run a development build. So it's advisable to download it once, store it somewhere, and then in each and every project you're trying to run a development build in, you just navigate to that file. So navigating to it, the distribution URL is going to change, and then when you run this, your npx expo run Android is going to generate your Gradle from that zip in your local directory. So let me show you how it's done. We'll head over to our browser and search Gradle releases, gradle.org/releases. In our project, it is using a Gradle 8.13 version. So we go back to our browser. This is our 8.13 version. You download it and save it somewhere among your files. Mine is done installing and I saved it in my desktop Gradle, and then I'm going to change my distribution URL. So it deletes the HTTP link that you had there before, and then you type this file column /c column / capital letter U / the name of the administrator of your laptop. Mine is Gami / where is it, desktop / Gradle / Gradle - 8.13 - bin.zip. If you check here, you see it's the same file. You see users Gami, desktop, Gradle, and then Gradle - 8.1. And then if you want to confirm that you wrote the proper directory, it's meant to show a line here. If yours is not showing a line, hover your mouse on top, hold Ctrl and click it. It is meant to show this. You can see users Gami, desktop, Gradle, Gradle.this. If it shows something like, let me alter something in the name, Gradles. If you click it, you can see unable to open this because it was not found. So delete this and then open anyway. So this is now that we have the Gradle zip file installed, and then we've also changed our distribution URL under our Gradle wrapper properties. Next up is to run it and then develop a development build. So we first check if there's any device connected using ADB devices. You can see list of device attached. This is a device. If you are using a virtual device on Android Studio as well, follow these steps. Like I said, using the physical device and using your virtual device follows the same procedure. The only difference is one is virtual and one is physical. When you connect your physical device to your Windows laptop, it's going to act the same way as the virtual device. This zip file that you've downloaded, you can use it not just for this project, but for any other React Native Expo projects that you're building and you're trying to access native features using a package. Features like QR scanner, they are native features. Mobile Wallet Adapter, they are native features. And so many more. Google Maps, locations, and stuff. They are all native files, and then they are all native packages. And they can't be accessed using the Expo Go because they have to tap into the phone system to get some information and some details and control the phone. So you can't use an Expo Go to test run those kind of apps. So you're going to use a development build. Next up, if you're using Android Studio, you open it up, come to more actions, virtual device manager, you click this plus, and then you download a new phone. You can see the small phone, this medium phone. Ensure the one you're downloading comes with Google Play installed. And then after you've downloaded it, my laptop doesn't have that much space, and then the RAM is not that high, so I can't use a virtual device to test run it. Instead, I'm going to be using my physical device that I connected to my laptop using my USB cord, USB cable, normal USB cable. Just make sure your laptop can actually view it, like it is recognizable by your laptop. After you've connected it through USB, next thing you're going to do is to go to your settings of your phone. You go down, you see build number, and then you tap it. You can see you're already a developer down here. You go back, look for where your developer options is on your phone. Developer options, you click it, you scroll down, and you see USB debugging. By default, your Android turns it off, so you're going to turn it on. Debug mode when USB is connected, meaning you are giving your laptop access to read and write into your phone. So once you turn it on, you come back here, and then you can type ADB devices. As you can see, my device is showing. So after I've seen my device, then I can proceed to type npx expo run android, and then you click enter. And here you go, Solana the app. Use developer menu, then you can see here you have it. Let's make a few changes on our app. Come to sign in, connect. You can see connect its wallets, or rather, let's see, connect with Phantom wallet. Mind you, this will connect with any Solana based wallet that you have. For me, I'm using Phantom wallet, so you can use anyone you have. Yeah, connect with Phantom wallet. You can change some other things to change this Solana dApp. So here you have it. You can make some changes, and then you're going to connect with Phantom wallet. It's going to take you to the Solana based wallet that you have on your phone, and then if you have more than one, it's going to prompt you to which one you want to use to log in. For me, I have only Phantom wallet, so you can see connecting you allowed to view balances and activity for the selected account. You click connect, confirm. Mind you, I'm in testnet mode on my Phantom wallet, which is why I'm able to view my balance, my wallet balance is sold, and then I can send, receive, and also request airdrop. You can request as well. I think I've used up my faucet for today. Let's try it and see. Oh yeah, you want, so this is it, 6.9998. You can as well send. If you come here, destination address, let me paste. You can see confirm transaction, confirm, and then you go back home. Our sold reduced from 6.99 to 5.99. You can receive as well. And also, there you have it, guys. This is a basic Solana decentralized mobile app where you can send, receive, and then view balance. And you can also tweak it as well, make some changes to your taste, count, layout, .tsx, choose the one you want. Should it be the non-airdrop button? And also, there you have it, guys. Thank you for watching, and stay tuned for more.